Hi everyone, I am Dr. Peiris. Welcome to the classroom. This course is the Digital Logic Design class and the today's topic is logic diagrams. So first I will show you the basic logic gates, then what the operator precedence we're going to follow when we draw the logic diagrams. Then I'll show you how to draw logic diagrams for 2 inputs, 3 inputs and 4 inputs. Now these three are the three basic logic diagrams. The first one is the inverter, and this is the gate symbol for the inverter. So what happened in the inverter is that it switched the input. This is the Boolean expression y equals a prime. So for the inverters we use the a prime, or this is also called as the a complement. So what happened in this inverter? When the input is 0, the output becomes 1. When the input is 1, the output is 0. So in the inverter basically it switched the logic 0 to logic 1 and the logic 1 to logic 0. The next one is the AND operator. So what happened in the AND operator? So in this case we have two inputs. The output y is written as a dot b. The dot represents the AND operator, or the AND operation between the input variables a and b. Sometimes we omit the dot to make it simple. If we just write ab, which means there is an AND operation between the input variables a and b. So two inputs a and b. So since there are two inputs, we must have four different input combinations: 0 0, 0 1, 1 0 and 1 1. Now if you look at the output column, you see there is only one logic 1, which means both inputs a and b need to be 1 to have an output 1. Now the third one is the OR gate. Again two inputs. The output y is written as a plus b. The plus represents the OR gate. This is not the arithmetic plus. So a or b is the output expression. Now if you look at the output column, so there are three logic 1s, which means if at least one input is 1, the output is 1. So that's the difference between the AND gate and the OR gate. Now let's see what is the operator precedence we need to follow when we draw the logic diagram. So first of all, you must draw the NOT gate, as well as whenever you have parentheses, you must draw the parentheses first. You should complete the parentheses part first, then the AND part, then the OR gate. Depending on what you have in the expression, these steps might change or skipped. So let's see some examples. So the first one is a circuit diagram with two inputs. So how do we know if you have two inputs, three inputs or four inputs? You must look at the given letters in your, you need to look at the given inputs. So this one we have a plus ab prime. So a plus ab prime, which means only two variables a and b. Two variables a and b. So which one we do first? The b prime, because it is a NOT gate. So first you can start drawing the two inputs a and b. So these are my two inputs. The next one I am going to draw is b prime. So which means I need to make that b goes through a NOT gate. Then it becomes b prime. So once I complete b prime, I must do the ab prime, because that is the AND operator and it is the first one that comes in the operator precedence. So ab prime means there is an AND gate for these two inputs a and b prime. So this is my a, this is b prime, then we do the AND between these two. So the output of this gate would be ab prime. So we finish that part. The next one is to do the OR gate, because we have a plus sign here, a plus ab prime. So what are the inputs to the OR gate? The one is definitely ab prime. So I draw the OR gate. So one term is ab prime and the second term is a. So I take a wire from here, so you draw a line and then you make it go to the OR gate. So this is the output. This output is equal to ab prime plus a. This is how you do the circuits. Do one term at a time, one gate at a time, and always you can write down the outputs of the gates that you draw so you don't miss any terms. Let's see this example also. This is also a two variable circuit. If you look at the expression, there is only A and B. So I'm just going to draw A and B first, my inputs. Then we need to look at if we have any complements. So you see that there is A prime, which means I need to make the A goes through an inverter. This is A prime. Then we follow the parentheses. So you complete the parentheses first. Inside the parentheses we have A prime plus B, and we know the plus represent the OR gate. This is A prime, and then B, they need to go through an OR gate. This is my A prime O B. Then what we have? We have A and then AND this entire term. So you need to do A and A prime O B, which means we need a AND gate. So one input is A prime O B, the second input has to be the A. So you take a connection from A, then that is the output F. Let's see another example. Now this case we have three inputs. So if you look at the given expression F, which is A prime O B C, so there are three inputs A B C. So the first thing we're going to do is to draw the three inputs A B C. Then we will look at if we have any inverters. Yes, there is an A prime term, so we do the inverter for the A. Now we have A prime. So what do we do first? So again, following the order of precedence, we must do the AND term first, which is the BC. So I will do the AND between B and C. This is B C. Then we have A prime plus BC. The plus represent the O. So between A prime and BC, we draw the O. The inputs to the O gate are A prime B C. This is the output F. The next one, so this is again a three variable question since we have three terms A B C. So let's draw A B C. A B C. Now what are the inverters? We have A prime and B prime in the expression. So you make A prime and B prime. This is A prime, this is B prime. Now what do we do first after we do the inversion? All the time we do the parentheses. So the first one we do is A prime plus B prime. Plus means the O. Between A prime and B prime, we do the O gate. This is going to be A prime O B prime. Now once you finish that, you need to complete the next part of that, which means there is an AND gate between A prime O B prime term and the C term. So we do this, and here is the C term. So these two must go through an AND gate. This part is A prime O B prime and C. The last one is to do the entire thing. So what is in between entire thing is the O operator. So between this and the A, so you take a connection from A, and they need to go through an O gate. So this is the final output F. So this is how you complete this type of questions, just one term at a time, and make sure you follow the order of precedence. The next one, draw a circuit with 4 inputs. So here you see the letters A, B, C, D, which means we are going to have 4 inputs. Now I am going to draw the 4 inputs A, B, C, D. Now then we do the complements first. So here if you look at the complement, I have a D prime, which means I need the inverter here. Then the parentheses. So what is in the parentheses? So the parenthesis is AOB prime, which means before we do the prime we need to do the AOB first. So you do the AOB first. AOB, this is AOB, this is an OR gate. Then you must do the complement, AOB prime. That means this need to go through an inverter. Then it becomes the complement. Now once you finish that, the next thing you must do is the AND with the input C. So here is the input C. Then they need to go through the AND gate. This is the AND gate. So the output of the AND gate is what? C AOB prime. See, the prime is outside, which means it is the complement of the entire term AOB. Now once we have this term and the D prime, they need to combine through the plus, which is the O. So we do the OR gate between these two. This is the output F. So this is how we can do circuit diagrams for many number of inputs. So that's all for today, everyone. So please subscribe to my YouTube channel, Dr. Peiris Classroom, as well as visit my website drpeirisclassroom.com for other videos and for other classes. Thanks for watching, everyone. I'll meet you again with another video.